We're given the graph of g of x, and we want to sketch the inverse graph on the same thing. So you already saw algebraically how we got that equation where we switched the x and the y and then solved for y. The nice thing about that idea for the inverse is it also works with your graphs. So the number one thing with the inverse is this idea that you're going to switch the x and the y. And so we saw that in the equation, you just switch the variables. With coordinates, here on the red graph, I've got -4, 4. So if I switch the x and the y, I'm going to have the point 4, -4. The next point is -1, -1. What happens if you switch the x and the y on that one? It stays the same. Our third point here at 1, 3 becomes 3, 1. And our final point, 3, 2, becomes 2, 3. And if we join them in the same order as before, this one to this one to this one to this one, oops, don't like that last line. Here we go. This one. Yeah, close enough. We get the graph of the inverse. Pretty cool. Is the inverse a function? Do you remember how to tell if a graph is a function or not? What does your gut say? Is the blue one a function or not? No? You're right, it's not a function. Is the red one a function or not? Yeah, the red one's a function. So what was it that you used to figure that out? The x value doesn't repeat itself. So in other words, for example, here the x value is 2, 0, and here the x value is 2, -2 maybe. So the x value doesn't repeat itself. Now there was a simple way to test that. I'm going to show you and I'm going to ask you if you've seen this before. It was called the vertical line test. So if you drew a vertical line and you took that vertical line and dragged it across to find out if an x value repeated itself, it would have to hit the graph more than once. So when we look at the red graph, and if I move this slowly across, can you see that that black line is only hitting one point on the red graph as I go? I never have a spot where I can draw that vertical line and have it hit more than one point. But on the blue graph, right away we hit 2 points. There's even some places, I think here, look, it hits 3 points. So if your function ever hits more than 1 point with a vertical line, then it will not, or sorry, not if your function, if your graph, because it's not a function. If your graph hits more than 1 point, then you can say it is not a function. Because it does not pass the vertical line test. And there only has to be one place for it not to pass the vertical line test for it not to be a function. It's still considered a relation. That's what you call something that has a relationship between x and y, but it is not a function. And then part C, state the domain and range of each. So we will do the red one first. The smallest value is -4. The biggest value is 3. And the range, the smallest value is -1. and the biggest value is 4. And even with the domain and range, you get this key idea of switching x and y. The domain are your x values. The range of the inverse is exactly the same as the domain of the original function. And similarly, the domain of the inverse is exactly the same as the range of the original function. Another thing to notice on this graph. Inverses are a transformation that is related to reflections because an inverse is a reflection over the diagonal line y equals x. Now, sometimes it's really hard to visualize flipping something over a diagonal line. And I'm going to show you how you can cheat on your final exam with this. You take your paper, they'll never notice. You take your paper and turn it until your diagonal line is flat, and then you'll be able to see how to flip it over a lot better. Right? Your brain, it's hard for your brain to flip over a diagonal, but if you turn your paper so that that green line is horizontal, can you see how one is a flip over of the other one? How this point, 3, 1, goes straight across to 1, 3. Okay? And they'll never catch you if you turn your paper. It's like, okay, I should probably not. I have this on the video. Oh no. Endorsing cheating. I'm going to be in so much trouble. Okay. Well, hope to see you guys on Monday. Anyways, there is our question number 1. Questions to do are 4 and 9.